Good morning, Mr. Herman here again. Today we're going to take a look at the idea of similarity. So far we've been looking at dilations, and we've seen the figures that dilations make, and now we want to be able to work with figures that we don't have to see the dilation happening to compare to each other. So if we think back to last year in Math 1, and also the other video the other day, we had translations, reflections, and rotations make figures that are congruent. Okay, we said that these are rigid motions, and rigid motions will generate congruent figures. So that means that they have the same size and the same shape. Dilations, however, will make figures that we call similar. Okay? So similar figures, if we think back to what we saw when dilations were created with our non-rigid motions, similar figures have the same shape, but they have proportional size. Okay, so think back to how we had scale factor with dilations. That scale factor is what we would call the proportion between similar figures. So we need to show similar figures with a different notation than we did congruent figures. So our congruent symbol is the equal symbol with the little squiggle on top, whereas similarity symbol is just the little squiggle. Okay? So let's go ahead and take a look at some figures and figure out, are they similar? Why or why not? So first off, we need to think about our definition. Same shape, proportional size. Okay, that means that our angles are the same. I'll write that in there as well. So all angles are congruent, and then all sides are proportional. Okay, so first off, let's take a look at our angles. So I look at my angles, A and D, and since they have one marking each, those are congruent angles. B and E both have two markings, so those are congruent angles. C and F both have three markings, and so those are also congruent angles. Okay, so it means that all angles are congruent. Okay, now let's check our side lengths. So I have 10 and 20. So I'm going to, like we saw last class with our scale factor, I'm going to do my image over pre-image. So 20 divided by 10 is 2. Okay, now let's take a look at this side. We have 6. This side we have 12. So let's go ahead and do 12 over 6 equals 2. Okay, so far so good. That those proportions have to be the same, and they are so far. Now we look at the last pair. We have 7 and 14. So 14 divided by 7 equals 2. Okay, so that means that all sides are proportional. So now we have to write a similarity statement. So just like we wrote congruent statements last year, we write similarity statements this year. So we have triangle ABC is similar to triangle. Make sure we line up our points. So we had A, B, C. So we need D, E, F. Okay. So let's go to our next pair of figures. We have two rectangles here. So we have right angle, right angle, right angle, right angle, and then 4 right angles as well. So we know that all angles are congruent. So let's look at our proportions. Now, since we have rectangles here, we have pairs of congruent sides, so 35 and 35, 42 and 42. We only need to check a couple of these. Okay, so I want to check my long side, 35, and my long side, 42. So let's do 42 over 35. So that equals, we're going to get a decimal. It's going to be 1 point, I think 1.9. Oh, no, not 1.9, 1.17. Okay. So now let's check our other pair, 36 and 20, and that's 1.8. Okay. So our proportions are not equal. Okay, so that's a problem. So if our proportions are not equal, our conclusion is the figures are not similar. Okay, so let's look at one more pair of figures, and this one's kind of gonna get us into what we're gonna talk about next week, or later this week rather, when we look at some properties. Okay, so if we look at our angles first, oh, whoops. There we go. So with our angles first, we have our big triangle, here, our little triangle here. Okay, so they both have angle B. So angle B is in the big triangle and the little triangle, so that's the same. Angle BDE and angle BAC, they look pretty congruent to me. We'll say why next later this week. Then we have angle BED and angle BCA. Those look pretty congruent to me. So we're going to say that all angles are congruent. Okay, now let's look at our sides. So let's look at this pair of sides first. 2A over A. So 2A over A. Got some variables in there. We got to think about A divided by A. That makes 1. So that equals 2. Let's take a look at BD and BA. So I'm going to put BA over BD. Now, since I have markings here, this is one marking and this is one marking, these have to be the same length. So I'm going to put a 2 and a 2. And over here, these have 2 markings and 2 markings. These have to be the same. So I'm going to say 3 and 3. Okay? So BA is 2 plus 2, 4. And BD is just 2. So that equals 2. Now if we look at BE and BC, so BC over BE, both of those, the whole length is going to be 3 plus 3 equals 6. And then BE, just one length, is 3. And so 6 divided by 3 is 2. All our proportions are the same. Okay, so let's say all sides are proportional. So we can make a similarity statement of triangle ABC is similar to triangle DBE. And there's similarity for us.